There is a bit of housekeeping needed in order to get going with the Raspberry Pi in terms of doing regular software development, particularly if you intend to write code from your normal desktop or laptop environment rather than with a monitor, keyboard, and mouse all plugged into the Pi. I highly recommend the former approach. It's the one I use, and it's the one that I'm going to assume that watchers of this course will be using. If not, you can skip the parts about remote command line access and easy file access. First up is allowing remote command line access to the Raspberry Pi. If you're familiar with Linux servers, this is going to be old hat to you, but in case you're not, the idea here is that we can remote into Linux machines and issue shell commands to them at a command line. For Windows programmers, this is on par with remoting into a machine and using PowerShell on it. I'm going to cover how to set this access up on the Pi and how to make sure it persists when you reboot. Then I'm going to show you how to install, enable, and configure a tool called Samba for the Pi. This is a tool that allows Linux computers to behave as if they were part of a Windows workgroup so that you can access their file systems the way you would with a shared drive on a Windows computer. This is also going to allow your Windows computer to identify the Pi by its machine name rather than by its IP address. There are a few other options for remote control over the Pi that I'll mention but not demonstrate. The first is RDP, the standard Windows mechanism for remoting into other computers. There is a utility out there that you can install onto your Pi to allow this sort of access. Second is VNC, which is a remote desktop access software that works across a variety of operating systems. Either one of these is an option for the Pi that's going to allow you not only file and command line access, but full-blown remote access. This is, however, beyond the scope of this course. Finally, I'll discuss installing the programming tools you'll need in order to proceed with the REST endpoint. I'll explain the Python package manager again in this context, as well as show you how to install Git so that you can source control your work or put it onto GitHub if you'd like. I'm not going to cover the installation of Python because that comes pre-installed on the Pi. Alright, first up is getting started with SSH. I'm going to do a sudo apt-get install SSH. However, as you can see, I'm using that program already, so installing it won't work and it won't be necessary. It's telling me I already have the latest version. A lot of versions of Raspbian are going to come with SSH pre-installed, but if they don't, that is how you would install it. Now, next up here, I'm going to show you how to start SSH with this sudo etc initd SSH start. But again, obviously it's already started. If I wanted to stop it, I would use the same command but with stop, and I can also restart it. But I'm not going to do any of those things because it's currently running and that would be a problem. So what I'll show you next is how you would make it start at startup every time when you boot. And you're going to do that with this update-rc.d, and you're going to set SSH defaults. And it's already set up to start here, but in case it weren't, you would now be configured for it to start on boot. And just for good measure here, what I'm going to do is I'm going to go ahead and reboot, and I'm going to show you what it's going to look like when you actually want to start logging in from an SSH client from Windows. And there you can see the machine is in fact shutting down. Alright, so now that the Pi is set up to host SSH connections, I'm going to show you how to install an SSH client on Windows that's called PuTTY. So what I'm going to do is type into Google download PuTTY, and that'll take me to the PuTTY download page. And I'm going to scroll down and look for the Windows installer. There are all kinds of different executables you can download individually here, but my suggestion is to go with this general installer. It'll download extremely quickly, and the installation process is going to be quite simple, so I'll run it. And then I will basically just breeze through hitting next at every point. As I said, this is quite a simple installation. And then once that gets up and running, we'll be ready to execute PuTTY and go ahead and log into the Pi. So I'm going to run the install. The install is going to go extremely quickly. I'm not interested in the README right now, and that's it. Now I'm going to go to start, and I'm going to run PuTTY itself. And I'm going to type in the IP address of the Raspberry Pi, which I happen to know on my network. And please note that I am having to access this by IP address right now. A little bit later, I'll show you how to make it so that we don't have to do that. So since the Raspberry Pi is still booting, it's probably just about finished. This is taking maybe a touch longer than normal, but it would come up generally pretty quickly. This is just asking if this computer that I'm trying to log into is who I think it is, which it is. And now I'm going to log into the Raspberry Pi with the credentials Pi as the login and then Raspberry as the password. And now I'm all set to move on to the next step, which is going to be Samba. To get started with Samba, the first thing we need to do here is install Samba. So as you've seen before, we're going to do that with sudo apt-get install and Samba. This is actually going to take a little while, so I will cut out and then come back shortly when it's all finished. So Samba is now installed. There's another package that needs to be installed, which is going to be done with the same apt-get that we're used to, and that'll be install Samba and then common bin. And this is going to give you a series of utilities around Samba. And I will let this go and come back again shortly. All right, so we're all set with that. Now we have the main things to do in order to have Samba installed. So I'm going to do ifconfig, which is going to show this machine's IP address right here, as you can see. Now I'm going to show you something interesting happens, which is that we're going to be able to actually view this in and from Windows. So there's nothing in this directory yet, which we're going to fix here momentarily, but that's a significant step. So just by installing Samba and the utilities, we get the ability to view this from a Windows share that we wouldn't have had before. So now I'm going to edit the Samba config file, and the first thing I do when I'm opening it is going to be to use the search function Control-W, and I'm going to search for a directory called Homes, and I'm going to change this browsable setting from no to yes. And what that's going to let me do, is I'll show you here, is it's going to let us take a look at the home directory. When we navigate back to this through the network, now that homes directory is there. So all we did was turn it on. If you try to actually open it at this point, bad things are going to happen. So I'm going to go back down using search, and I'm going to find homes again. And now I'm going to insert another entry here above homes that we configure. This is going to be another folder that you see next to homes. So I'm going to set its path to the local path on the Pi, which is home/Pi. And then I'm going to start setting some certain file-based settings here. We want it not to be read-only. We want to be able to write to it. We want it to be browsable, of course. And then I'm going to say the guest is okay, which means that we can do pretty much anything we want on this. This is very permissive. We're going to set these create mask and directory mask properties, which is very Linux specific, so just kind of take my word on that for now. And what that's going to do is create an extremely permissive share that you wouldn't want to do if you were exposing to the network, internet in general. And there you have it. Now we can actually access that directory on the Pi, which is pretty cool. So you're pretty well set up to start using this as if it were just anything on a Windows network. And you can see that we've also now gained the ability to see it as Raspberry Pi instead of with just the IP address. So now I'm going to do the last couple of things, which is to install the Python package manager, sudo apt-get install python pip, and we'll come back and let that install after we say yes here. And there it's done. That took a minute or so. And we're going to do the same thing in order to put Git on this machine. Git may or may not be on your machines. I believe it is on this one. Yes, already installed, but if it's not, that's how you install Git, and you're all set to develop.